The graph of a quadratic function f of x has a minimum at negative 2, 3 and passes through the point 2, 13. The function g of x is represented by the equation g of x equals the negative of x plus 2 times x minus 3. The question is, how much greater is the y-intercept of g of x than f of x? So for f of x, what you know is the vertex is negative 2, negative 3, and it passes through the point 2, 13. What we're going to do is take that information and substitute into vertex form. So vertex form of a quadratic function is f of x equals a times x minus h squared plus k, where h and k would be the xy coordinates of the vertex. Standard form of a quadratic function is f of x equals ax squared plus bx plus c, where c, the constant term in standard form, is the y-intercept. So for both of these, f of x and g of x, we're going to get those in standard form so that we can compare the y-intercepts, compare the constant terms. Again, we're going to substitute this information into vertex form. That vertex, negative 2, negative 3, that's going to go in as h and k. H is the x coordinate of the vertex, k is the y coordinate of the vertex. And then this point 2, 13, that's going to go into vertex form as x and y. 2 is going to go in for x, and that 13 is going to go in for y, which as you know is f of x. So when we substitute in, negative 2 goes in for h, negative 3 goes in for k, 2 goes in for x, and this 13 goes in for y, which again is f of x. So you have 13 equals a times 2 minus negative 2 squared minus 3. Simplify that. 2 minus negative 2 would be 2 plus 2, which is 4. Then square that 4, that is 16. So you have 13 equals 16a minus 3. Add 3 to each side. When you do that, get 16 equals 16a. Then a is 1. What do we need that for? Well, we're going to take that a, which is 1, substitute that into vertex form, along with this negative 2, negative 3. So we're taking that vertex of negative 2, negative 3, along with this a being 1, substituting into vertex form. After we do that, then we're going to get it in standard form. So put 1 in for a, negative 2 in for h, and negative 3 in for k. So when we do that, you have f of x equals 1 times x minus negative 2 squared minus 3. X minus negative 2, that is x plus 2. Now that 1, you can drop that off. 1 multiplied by anything is itself, so you can drop the 1 off. Also, when you square that x plus 2, when you square a binomial, you're multiplying it by itself. So take x plus 2 times x plus 2. That is going to be x squared plus 4x plus 4. With the FOIL method or distributive property, multiplying those two binomials, you get x squared plus 4x plus 4. And don't forget, you still have that minus 3 on the end. So to finish this off, getting this in standard form, combine 4 and negative 3, combine the like terms, that is going to be 1. So you have f of x equals x squared plus 4x plus 1. Now we can see on f of x, the y-intercept is 1. Now for g of x, we want to get this in standard form so that we can compare the y-intercepts. So for g of x, which is the negative of x plus 2 times x minus 3, we can multiply those two binomials together. X plus 2 times x minus 3 with the FOIL method or distributive property, that's going to be x squared minus x minus 6. Then distribute that negative sign through the parentheses. It'd be negative x squared plus x plus 6. Watch your signs. So that is standard form. You can see that the y-intercept of g of x is 6. Now we know the y-intercept for both of these. The y-intercept on f of x is 1. The y-intercept on g of x is 6. The question was, how much greater is the y-intercept of g of x than f of x? And now, finally, you can say the y-intercept of g of x is 5 greater.